Welcome to the LRC, where we'll teach you all about the science of motion with my favorite knockoff race car, Leteneng Mcquan. The science of motion that we are discussing in this video is called kinematics. The dictionary definition of this is a branch of mechanics that deals with the motion of objects without considering air resistance and friction. The simple version of that is it's just physics without forces. Leteneng Mcquan over here has to burn gasoline to push itself forward, has to deal with air resistance, let's say if the wind is really strong, pushing him back and making him slower, and also has to deal with things such as terrain, let's say if there's rocky ground, slowing him down. The thing is though, for kinematics, we do not care about any of these forces. First, we put Leteneng Mcquan in a vacuum. This means that we assume that all environmental conditions do not exist. Things such as rain or rocky ground are things that are not relevant. Moreover, we do not consider any of the forces that would push Leteneng Mcquan. The gasoline that he burns in the engine that pushes him forward, we do not consider, nor would we consider somebody pushing Leteneng Mcquan. The only thing we care about truly is the motion, making kinematics the science of motion. Moving on, it's time to talk about kinematics terms. However, before we go on to that, there are two classifications or quantities that you need to be aware of, which most kinematic terms can be split into. These being scalar quantities and vector quantities. Scalar is magnitude only, which means it only cares about the number. And vector is magnitude plus direction, which means it cares about the number and also the direction at which the object or whatever else is moving. To give you an example of this, we have speed and velocity. Both of these sound like the same thing, but speed tracks the rate at which an object moves and only the rate at which an object moves because it is a scalar quantity. Because of this, if we put here 5 miles per hour, which is Leteneng Mcquan's speed, Leteneng Mcquan could go 5 miles per hour to the left, 5 miles per hour to the right, or ascend to heaven and go 5 miles per hour up. It doesn't matter, and speed does not keep track of where Leteneng Mcquan is actually going. However, for the velocity, it is the rate at which an object changes its position, and it is speed with direction. This means that it actually tracks and gives the additional information of the direction of this car. If we were to write down the velocity for Leteneng Mcquan, it would be 5 miles per hour, like speed, but it would have to have the direction, let's say west. And because of this, we know where Leteneng Mcquan is going. It's going west. Let's give you a different example of scalar and vector quantities. Distance versus displacement. Both of these sound like the same thing, but distance over here is a scalar quantity and it tracks the length of the whole path traveled. So let's say Leteneng over here decides to go the long way and goes from A to B and B to C. Note that all of the sides of this triangle are 5 meters. So A to B is 5 meters and B to C is 5 meters. So let's say he does that. The distance would track it as 10 meters because he went 5 meters from A to B, then 5 meters from B to C. However, displacement is a different story because if you notice, there is a shorter path to this triangle. Leteneng could have went from A to C without having to cross through to B. And displacement tracks the change in position with direction, which basically means it tracks the fastest way to get from where you were to where you went, C. So it would track the distance from A to C, which is only 5 meters, and it would basically say the displacement of this car is 5 meters east, because technically it's only 5 meters away from where it started. Okay, now that I'm done with that, it's time to move on to another term, acceleration. Acceleration is the rate of which an object increases in velocity. It is a vector quantity because it always includes the direction the car's velocity is going in. So let's say this car is going to the west. We don't have to put there that the acceleration is like 2 meters per second to the west. We can just kind of ignore this part because we already know that the car is going to the west since the velocity of the car says it's going to the west. So even though we don't have to add like the north, south, east, and west values for acceleration, it is a vector quantity. Okay, now that that's done, let's talk about the two different types of acceleration. First, we have initial acceleration. This is the car when it's starting out. So let's say this car goes from 0 to 15 meters in 3 seconds. That means at the start, it has an initial velocity of 5 meters per second. However, final velocity checks what the acceleration is at the end of the motion. So let's say the car has its start and slowly zooms out of the screen, right? Like it goes from there and then it goes super fast. That means we have to have a separate value, which is what the final acceleration is for, because it checks the acceleration of the car when it is at its end, when it is already finishing the motion. So if, let's say, that's 15 meters per second, because the car suddenly sped up. Okay, that's it for acceleration. So it's time for the last two and the easiest two of the terms. First, we have time. It's just the duration over which the motion took place. And basically just means however long Leteneng Mcquan has been driving for the problem. Let's say the problem says Leteneng Mcquan has been driving for 10 seconds. That's the time. That's the time that Leteneng Mcquan drove for. And that's what you put over here. Gravity, however, is a tiny exception to the rule of there are no forces in kinematics. That's because most kinematics problems also deal with vertical motion, for instance, Leteneng Mcquan going up, which means unless we want them to go up forever, we have to use some force to keep them on the ground, which is why kinematics actually cares about gravity. The way kinematics gets around having using this without breaking the no forces rule is it considers gravity a form of acceleration. The negative acceleration I mentioned to you earlier is a good example of this because gravity is technically just negative acceleration to anything going up. For instance, if Leteneng Mcquan over here is going 10 miles per second up, then gravity resists him and is a form of negative acceleration which forces uh, Leteneng Mcquan to go down as he goes up. So he can go up to a certain point and then the negative acceleration takes over and forces him down. Okay, that's it for all of the terms. Here are the classifications of all of the terms that you can screenshot. I'll get my mouse out of the way. And that's it for the science of movement. Thanks for watching, and I hope to see you in the next lesson. Bye.